Just arrived a couple of hours ago, and now I'm going to unbox it. So packaged in here, we've got one shredder. Today, I'm going to be going in depth about all things plastic shredder. You may be wondering why I'm in front of a green screen today. That's because a lot of what I'll be talking about today will be on my computer. And so I'm mostly just going to be ahead in the corner speaking to stuff. First of all, let's actually have a look at the shredder. The shredder is here right now in front of me. Let's have a look at it because it's just exciting to actually see the thing in your face. Let's go. Here's the shredder right before your eyes. It just arrived last week. I'm gonna just use some rubber gloves on this because it's been greased up and I don't like to get my fingers as gunky, but there you go. Now, one thing to actually note, the mesh inside is causing it to grate a little bit. It's not quite as smooth as I would like it to be, like it is in the original Precious Plastics video, but it really doesn't require too much additional power to get it through. I'm just gonna flip this guy over. And there you go. There's the mesh on the back. That's the 5mm mesh that's already been put on. I did test and it was very easy to remove these screws and get it off if I want to put the other one on. There you go. That's the 8mm mesh comparatively. So you can kind of see the difference in size. It's quite a big difference. And you know, ultimately, if I choose to go with this mesh, that means consuming less energy to get plastics down to this size. If I want to go with the 5mm mesh, I'm looking at more energy to get it down to this size, but 5mm is the most ideal for putting through an extruder. I think it's time to just get started on basically walking through everything about the shredder, and let's see how up to speed I can get you. What I want to do is I actually want to show you a couple of videos I'm going to run through pretty quickly and just point out some approaches taken and how I'm combining those ideas and some of the things I'm going to be applying on my own as well too. So I think first and foremost, let's go through the actual tutorial from Precious Plastics. They're going to be building this from absolute scratch.
This is the machine we're going to build, and basically it consists out of 4 different parts. We have the shredding part, the power supply, the framework, and the hopper.
Yeah, I mean, this is obviously a part that I did not want to do from scratch myself, so I basically bought a shredder pre-made, so this part is not super relevant to any of the problems I'm going to be facing because mine has actually already been assembled. And here he is pulling a motor with a gearbox attached to it off of something in a scrapyard.
Sorry. So here we have our beautiful engine. It doesn't really matter how it looks or how big it is or the size. We only need to make sure
he really doesn't cover the fact that this has a gearbox in it.
We need to attach the motor,
and that's what is ultimately allowing it to move so slowly.
We'll give it a paint job.
But the whole concept of both motor and gearbox potentially being acquired separately from one another is something you potentially have to think about. And here he is, I mean, cutting a whole bunch of metal and welding, and I mean, none of this stuff I want to be doing ultimately. But I mean, I admit it looks really nice when you just weld the parts precisely to what you need. That's a slick little machine. And running and jumping up to a shredder like that is not something I would personally do. And so yeah, just like cutting metal out of metal like this, obviously something I don't want to be doing. I want to find a way to make a hopper without having to do a bunch of metalworks kind of stuff.
There's a big difference between shredded plastic without the mesh and with the mesh. Do note that the smaller you want your plastic to be, the more energy and the longer it takes. You can play around.
So that's an important thing to pay attention to.
Sorting out different colors.
The smaller the plastic, the more energy it's going to take to get to that point. A few thoughts coming out of it. They don't really talk a lot about what went into picking the motor. They don't talk a lot about any of the wiring that went into that box or what is ultimately making it reversible. I mean, the engine itself is reversible, but you still have to do some wiring in there to get that functioning out properly. And then, I mean, all the welding going on is something that is kind of out of scope of what I want to be doing. Now let's go to YouTube and watch another video. And this is the one that I think actually really got me first inspired and made me feel like, hey, I can do this, because it addresses those problems of welding, which I don't want to do at all. He runs into some interesting motor-related issues as well, which is something I've considered. Let's have a look.
Today, I'm going to show you how to recycle waste 3D prints with this epic precious plastic shredder.
So his goal is to recycle PLA used from his printer again. Not so much looking at household plastics, but wanted to build a printer for 3D printing purposes. I think this actually goes to show why, I'd say didn't end up using something like a paper shredder, because it can do it, but it's really not made for it, and it will have some problems with it. And look at the results on the other side too, right? No concept of a mesh or sieve to really break it down to the small pieces you need.
There's only one problem, however, and I needed something with a lot of torque to drive it.
A lot of torque to drive it.
Website, they recommend getting an old industrial electric motor with a gearbox. But this was too inconvenient.
So he mentions the gearbox.
Instead, I found a cheap winch on eBay capable of lifting 500 kilograms, so I figured the torque was going to be up to the job. Another huge advantage was that all the wiring was already done.
This is also smart.
Forward-backward switch as well as
using a winch means the controlling for the forward and back is already set up for you. But it does mean that you're ultimately going to have to disassemble the winch. There he is with the rubber mallet. That makes me a little bit uncomfortable, just bashing something off with a mallet, but it worked for him. And this is another key thing. So he makes this specialist bench, doesn't require any welding whatsoever. He just bangs it together with a rubber mallet and puts some particle board on top, and there you go. I really like what he's doing here, ultimately choosing to use some aluminum sheets, some like L brackets you call them, and then just riveting things together. I really like this approach. And then combined with the plastic sheets that he's going to put inside, I think that this is really smart. He's also going to put some hinges on them so that you could potentially reach in and you have a lid on the top, and I think that's all really smart stuff. Obviously it needs some safety mechanisms around it, but I like his thinking here a lot. Nice looking. Obviously you don't want to be reaching in when it's running, but it's pretty convenient to have. And you can see the coupling he's used here has really caused him a lot of trouble. I think that ultimately what I end up designing is going to be a lot closer to what he did. He accomplished a lot of similar goals to what I have. Avoiding all the welding completely. That's a huge one. I'm very inspired by the way he did the hopper, see-through. I think that's really cool. And then having flaps for reach-in is really interesting. No safety mechanisms built around that on his machine. I did actually notice some of the people in the comments of his video were saying something about that, and I do think that if I did did this, I would try to implement something like that. I have an idea to basically just run some wiring all through that, you know, if any one of these wires in the flaps is not connected, it's just going to kill the whole machine, and then feed that through like a very low voltage circuit to a relay that would then power the main motor and allow it to run or not. So we've taken a look at a couple of videos that were huge inspirations to what I was building. One was obviously the official Precious Plastic one, and then one was done by a guy on YouTube who I think had a lot of really good ideas for practical ways to go about this, to get things like a see-through hopper and not have to do any welding in the process. So I want to just take you through a Fusion 360 design of the sort of high-level plan of what we think we might be putting together, my dad and I, who are going to be building this machine. So here's my machine, which I have been putting together in Fusion 360. Precious Plastics actually provides a CAD design of the shredder itself, so that was really easy to find. It comes with a version of the hopper on it. This is not quite the approach I want to take with the hopper, obviously, because I want this to be see-through, but that just sort of came with it there. Even the parts I have here, I mean, I just found a gearbox and a motor to try to give me some idea of what the size of these things would be, but the actual result will probably look nothing like that. Just for fun, I mean, I threw in a little design of what it's going to look like with the plastic coming out and where I would potentially put a second row to put the container on so that it fits just under. I wanted to zoom in a little bit closer and pay attention to what's going on with the chain. A couple of reasons why we wanted to take this approach was so that we didn't have to worry as much about the alignment of these two things. You can kind of see from the side, they don't actually necessarily have to be the same heights as one another this way. And I also liked the idea of actually being open to potentially using the shredder inside of a different machine, maybe a bike powered one. And I thought it would be easier if I just set this up to work with sprockets, that if I wanted to try using a bike to power it instead of a motor sometime in the far future, it would be ready to do something like that. Okay, I think that kind of summarizes everything there. The requirements for the shredder itself according to the Precious Plastic website. So a couple of key things I wanted to point out here. Number one, interesting enough, actually, they're talking about 380 volts. Motors I've been looking at are more 120, 240. So that's a very high voltage they're talking about for this shredder. Nominal torque, 300 Newton meters minimum. That's a very interesting thing, actually, that they say minimum, because a lot of research I'm doing is sort of showing that 300 Newton meters is a lot. It's hard to potentially achieve without some compromises in either price or RPM of your motor. And 150 can accomplish a lot. I think when they're talking about 300 Newton meters, they're talking about really being able to crunch up some pretty thick plastics that probably aren't like the ones you're getting from the disposable polypropylene containers. And output speed about 70 revolutions per minute. And we'll talk about this a little bit more. So those are the specs as they have put them out. Now, my dad and I already made a trip to the store to try and look at some motors and some gearbox solutions to see what was out there. And we very quickly realized we potentially didn't have enough information in order to make the right decision. And it's probably a good thing that we ultimately felt that way, because I think we sort of realized the motor gearbox combinations available at the store weren't going to be strong enough in terms of torque for what we need for this shredder, or we didn't quite know what to look for. Like, there is motors in different sections for different purposes, and you know, different motors, depending on what you're using them for, need different levels of horsepower, RPM, torque, like all sorts of things kind of come into play. So we ultimately decided to do a little more research. And I mean, one of the things that was really interesting of the gearboxes we found, the strongest one could do 880 inch-pounds of torque. And when you convert inch-pounds, I believe it's about divide by 8.8 or so. So 880, well, that's pretty easy, 8.8. That means 100 Newton meters of torque was the highest on the gearboxes that we were finding at this store. And it's saying a minimum of 300. 150 seems like it could be satisfactory, but 100 is not 150. That's too low. I'll just share a spreadsheet I have here looking at a few options. And I still have to do more research on ultimately the right combination, but there's a really important thing to point out here first and foremost. I looked at a winch option, and when you look at the technical specifications on a winch, you're not even getting the same stuff as when you look at a motor. You know, it's not really talking in RPM the same way. So it's a little bit hard to read what a winch motor is going to get you. There's one really useful tool that I found by searching that came from Dave Hackens, the guy who runs Precious Plastic. This little tool is going to help me put in the RPM of a motor. So let's say it's going to run 1750 and it's going to have 1.5 kilowatts of power. And then the gear ratio is going to be 30:1, let's say. So now we can see, for example, here, that's going to give me good RPM, decent torque, but I may still be dealing with occasional jamming on thicker plastics, right? Now, even getting to this point, 60 RPM, 184 Newton meters. The closest thing I could find so far that accomplished close to that will cost me, because of the gearbox that needs the high enough torque output capabilities costs about $600. I can find a solution like that for no less than $900 right now. And maybe I need to do more research on that ultimately. And if I'm gonna go that far, for an extra $100, I can get great RPM, great torque. I just have to consider that I'm gonna need a higher voltage potentially, and I'm going to be using more electricity to run this shredder all of the time. And then again, looking at this winch option, because again, I didn't necessarily know what the RPM was going to be, but by putting in what the voltage of the motor was, knowing its hertz, its poles, and knowing that these winches tend to have something like a 150 gear ratio inside very often, I calculated a winch is probably giving me well over the torque that I need to run the machine, but it's going to be rotating quite slowly. And because of the way winches are built, they don't have any cooling mechanisms built into them. So it's recommended that you're only running it for 2.5 minutes every 10 minutes. So I can basically run it for 25% of the time and risk it overheating if I just let it run continuously. Some of these winches may actually even turn themselves off automatically if they find they're overheating as well too. It would depend what I look into. So where I'm landing right now ultimately is that a winch seems to be a very cheap solution that comes with a really strong gear ratio that allows for a high torque, but it's got low RPM, and I'll need to disassemble it. But I have not found any sort of medium price solution that's going to get me high RPM and really good torque without starting to spend hundreds of dollars more. Right now, I'd say I'm potentially leaning towards the winch solution, just because I don't think I'm going full industrial yet. Spending an extra $600 right now to get the full RPM and full torque for types of plastic that may not be coming by me very often is probably not something I want to invest in right at this time. I've got 2 other machines to be dealing with this summer as well too. I've got an extruder I want to build. I've got a new 3D printer coming that's going to be a kit I have to assemble. I've got a lot of work ahead of me to just prove that this whole pipeline is even possible. I don't want to start overspending on the shredder right now, I don't think. So I want to do a little more research, see if I can find some good medium solution. I need to research winches more in general, but that's where I'm kind of landing on figuring out this very important part of putting the shredder together. From there, I still have to figure out a little bit with the right sprocket solution. Is a sprocket chain solution a good idea? Maybe there's reasons why it's a bad idea, and I really should just look at doing a proper form of coupling, which I can get some help around. Those are going to be the biggest problems, and then it's pretty much just put it all together on a frame and see how it works. The hopper is not something I'm super concerned about being a real big problem right now either, and the circuitry of adding a safety layer, circuitry at that low voltage is something I'm very comfortable with, open to putting a microcontroller into this if necessary to add additional safety mechanisms. I don't want the safety mechanisms to be driven by the microcontroller. Like if a flap goes up, it kills everything, including the microcontroller. The microcontroller is only, for the purpose of being a timer or something, but I don't want to rely on a microcontroller to be in charge of my safety at the end of the day, right? Because then I'm ultimately relying on my own programming for the safety of my fingers. And that's just, I don't trust my programming enough for that. I think I'll try to do a dedicated episode on every component. So I'll do a dedicated episode on the extruder, although it probably won't be anytime too soon. I will try to actually even do one maybe on injection molding and what goes behind that. That's something I'm curious about, even though it's not one of the machines I plan to be building right now. And I'll do one about the 3D printer. Like I said, I'd like to do one about plastics in general. I am going to keep trying to do research beyond just how to build these machines, but actually into trying to understand plastics and the plastic problem in general. I think that just about summarizes everything. So thanks so much for watching. Take care. That's not a cool way to end it at all. Well, we're done here.